Now that you're familiar with variables and methods, we have to ask a fundamental question. Where do we put them? C# in general likes you to organize your code inside of classes. So that's the first point of a class, is organization of your code. There's another point of classes that we're going to learn as we work through our examples using the site csharppad.com. So go there now and let's begin. Let's define a class. Public class, and let's give it a name, my car. Then open a curly brace and some way down close a curly brace. So this class defines something called my car. Now inside of the class we can define some properties or variables that belong to my car. We can have an integer of top speed. We can have a string of color. Now all classes in C#, for the most part, need what's called a constructor, and this is a method that fires off whenever the class is instantiated. I'll show you what instantiation is in a little bit, but for now just know we generally need to have this method. This method is called a public and it has no return type, but we do not type void for it. We simply say public my car. And we can pass this some arguments or data if we like. Let's pass it over integer past top speed and a string past color. Open our curly brace and close it. Now let's pass over these passed in items to the class level variables. So top speed is equal to past top speed, and what have we got here? We have color is equal to past color. So when we instantiate this class, we will be forced to pass in these items that then get spread or assigned to top speed and color. So this class so far has two variables and one method. We can continue adding as many variables and methods as we like. So let's have a method that allows us to access the top speed of the car. Public int. And when we type int, we're implying that when we call this method, we're going to pass back a result which will be in the form of an integer. Get top speed. Open and close brackets because we're not passing any data. Open your curly brace and close it. So what are we going to pass back in integer form? Well, we want to give back this top speed. And you may ask, why don't we just simply go here and grab the top speed? Well, that's kind of a bad thing to do in C#, because if you simply access this straight away, anybody else that's working on the same program might do the same thing. And one of you will modify this, the other will modify it to what they want, and in the end you get what's called spaghetti code. No one knows who's doing what. So you can think of methods like this as public channels that you must use in order to access variables in your class. You should never access variables directly. So in getTopSpeed, we are going to return the top speed. Now let's have another method. Let's have a public void paint car. And this is going to pass over a string with a lowercase s called new color. And this string we're going to use to paint our car. So color is equal to new color. Whoops, I just tried to save it there, but it's a web page. I always forget that. Okay. Now I'm just going to copy this class because we're going to reuse it a little later. But just looking at this, we have now defined a class that holds the blueprints, if you will, for something called my car. Now, the word blueprint here is very, very important. That is basically the main function of a class. It's a blueprint that holds instructions that relate to creating a kind of object. So this one has the blueprints for a car. The car has a top speed, it has a color, you can get its top speed, and you can paint the car. And this is something that you could apply to any car that you see on the street outside your window right now. So a class in and of itself doesn't actually do anything. What we have to do is called instantiate a class. And this is just a big fancy word that means we're going to make an object using that blueprint. So this object is a variable in a way, like we've already experienced strings and integers. This variable, however, has a type of my car. So let's type my car Toyota is equal to a new my car. And when we open up this bracket, it goes over to that public my car and asks you for some top speeds and colors. So let's pass it 89 and a color red. Now we have created a new car called Toyota. Let's print out the top speed of this Toyota. Console.WriteLine Toyota dot, and now these methods that we defined earlier become available to us. Get top speed. And let's convert that to a string inside of our console write line. So this is going to open up a new object based on the blueprint of my car. It's going to be called Toyota. It'll assign a top speed of 89 and a color of red, and then print out that top speed to us, but it's going to access the top speed using this access method here. So let's click go, and hopefully that all works out. And it has. Now, what if we wanted to paint our car a different color? Well, let's copy all of this again. And let's paste it. So we have our car class. We have Toyota, which is red. And then underneath that, in our console write line, let's paint our car. So Toyota dot paint car, and this asks us for a color. Let's have green. Now, when I run this, our car color will change to green, but we don't know because we haven't printed out anything to the console. So that is the basic idea of classes. They hold blueprints that allow us to define new kinds of objects. Classes are one of the fundamental concepts of object-oriented programming. Now, you may have heard that term before, but this is where it fundamentally comes from. We have blueprints and we create items from those blueprints, and those items are generally called objects. I could have a Toyota object, a Ferrari one, a Nissan one, whatever we liked. So object-oriented programming always thinks about the objects and not really about the classes. The classes do their thing, but we always focus on the Toyota that we made or the Ferrari that we made from that class.